radical can be formed. So this kind of free radical is formed because of your homolytic cleavage of any atom or any molecule. So homolytic cleavage, in the sense, usually the normal chemical process which is happening will be heterolytic cleavage, which means you will be getting, for example, Na plus and Cl minus sodium. Sodium chloride, if you just break it out, you will be getting Na plus and Cl minus. So it's not a homolytic cleavage because you get a charged molecule. Na plus you are getting and Cl minus you are getting. Wherever you have minus, you have extra electrons, plus you have lost your electron. So you are getting ion formation. So these kind of ions can be existing in the biological system as a stable conformation atom or a molecule. So these kind of things will be used for the biochemical reaction or any biochemical processes or any biological mechanism like your action potential, carrying of signal, all those things, you will be using those charged stable atom or ion. Whereas here what happens in case of your free radical, of course you will have homolytic cleavage. I have just put an example of chloride molecule ClCl. So you just see you have ClCl bond. It's a molecule because it has two chloride ions which has combined. So in the presence of light, of course, whenever you wanted to break a bond, you of course use up the energy. So the energy can be in the form of light or photon, or it can be in the form of heat. So whichever is the form of energy you want, you can use up those energy, and you can just see these two chloride molecule, these two chloride atoms, you just break it up in the presence of photon of energy or photon of light energy, which is h nu. So once if you break here, since we are talking about homolytic cleavage, whatever the electrons which were shared by this chloride, which is your first chloride, and the next chloride, that will be equally taken up. So usually in the heterolytic cleavage, when it happens, whatever the bonding electrons you have here, that will be taken by means of one atom itself. The other atom will become negative because it would have lost the, positive, it would have become or lost the electrons. Whereas in case of your homolytic cleavage, you just cleave this bond, whatever the electrons these two atoms were sharing, that will be equally distributed. For example, if you have only two, one will be gone to this chloride, one electron will go to this chloride. In case if you have shared 4 electrons, 2 and 2 will be shared in case of homolytic cleavage. So now here what happens, you just see it's cleaved, whatever the bonding electrons you had, one is taken by one chloride atom, the other one is taken by the other chloride. So now you just see 1, 2, 3. 3 pairs of electrons are as such, it is satisfied. Whereas in case of this electron, which you got because of the breakage of this bond, you are having one unpaired electron. So now this particular chloride atom is a free radical because you have unpaired electron. Of course, the valence shell is not satisfied. So once if the valence shell is not satisfied, those molecules or atoms also can be called as free radical. And I hope everybody remembers octet rule. So always to have a stable conformation or a stable structure of an atom, you should have in the outermost cell 8 electrons. So once if we are having 8 electrons, then only the complete atom is stable in conformation or stable in structure. So now whatever has formed because of your homolytic cleavage, you will have free radical. You have the formation of free radical. That is why they usually tell, when you walk in the hot sun, whenever you get exposed to the ultraviolet irradiation, not in the morning or evening sunlight, in the mid of the day, if you just walk in the sunlight, your face, sunburn, suntans, all those things will happen because of generation of these kind of free radicals. So always for that, what you guys will eat? You will be eating most of the fruits like oranges, lemon juice and other stuffs. Do you know why you are using all such things?
Contains citrus in them, ma'am.
It is citrus, and also these kind of substances which includes your vitamin C, ascorbic acid, which is antioxidant in nature. So always when you increase your oxidant level in your body, always you should balance it with antioxidant level so that the redox potential of your system or your biological, any species it can be, it will be balanced. So the nature is made and set in such a way that whatever oxidants are produced, for that your body will have antioxidant mechanism to combat it. So in case if you disrupt your antioxidant mechanism in your body, then only whatever you told, your diseases will be caused, your other conditions and other biological disturbances will happen whenever the redox potential or the redox balance of your biological system is affected. So now you just see, as I have told you, you have one missing electron, and in the stable molecule, according to the octet rule, 3, 6, 7, 8. So in the outermost shell, you will have your 8 electrons to attain a stable molecule or a stable atom or a stable structure. So this is a stable structure or the stable conformation, whereas here you have your free radical, which is your unstable structure or the unstable conformation. So you have a missing electron. So you just see, I have put some few examples for it. So this is your oxygen molecule. So it's a stable structure. That's why you can see it is existing in the atmosphere. You inhale it. Your HP is carrying it to all the cells. In the mitochondria, it is used up as an electron acceptor to convert into water molecule. So here you just see 1, 2, 3, 4, 5, 6, 7, 8. Because it's a covalent bond, you have the equal sharing of electrons. So you will be considering as 4 for this oxygen also and this oxygen atom also. So you will be having octet rule. According to octet rule, you have 8 electrons. So it's a stable structure. Whereas in case of superoxide anion or peroxide or hydroxyl radical, you just see what is happening. 1, 2, 3, 4, 5, 6, 7, 8. Octet structure is done, but still you have one extra electron pair. So now how you just name it is by keeping dot, you will just put one minus, which means you have extra electron, so minus of course, and one dot, it's a free radical, and here it is only one minus, which means you have to understand it is -1. So -1 means you have one unpaired electron in the structure. That's why this particular structure you are denoting it as dot and one minus. So in case of peroxide, you just see the same two oxygen atoms, and here you have two unpaired electrons. Are you able to see red color dot? One from this atom and one from this atom. So you have two unpaired electrons. So how will you name? It is simple. Oxygen O2 molecule dot for free radical, and -2 or 2 minus is usually this 2 denotes 2 unpaired of electrons, 2 unpaired electrons. And here of course hydroxyl radical, because this one of the atoms is replaced by hydrogen. So one oxygen, one hydrogen. So here it is balanced. So here the sharing has been balanced here. Whereas this side you have one unpaired of electron. So it is hydroxyl radical with one unpaired electron. So it is OH only dot. So why I have put this hydroxyl ion? Hydroxyl ion is not a free radical because it does not have unpaired electrons. It's a charged molecule. So how you differentiate the charged and free radical is that you just check here what is happening. You have 1, 2, 3, 4, 5, 6, 7, 8 oxygen and hydrogen. It is satisfied, but the valency is not satisfied. The valence bonding is not satisfied. That is why it is OH minus. Here you don't have any unpaired electrons. So that is the difference between the normal ion and free radical. In case if it is a normal ion, the normal ion will have a satisfied valence shell, but the valence bonding is not satisfied. So here you will not have the bonding satisfied. That is why it is ion. Whereas here you have unpaired electrons. Either it will just accept an electron, or usually it just donates the electron so that this particular free radical will attain a stable structure. Clear? Have you all understood till here?
Yes, ma'am.
Are you all awake?
Yes, ma'am.
Okay. So now just see, we'll see. You know now what is free radical, how it is going to affect the biological system. So your free radical, you just group into two varieties or two major free radicals. One you call it as reactive oxygen species, which is your ROS, and the reactive nitrogen species. So based on the presence of oxygen and nitrogen, you generate the free radical. So obviously you classify the free radical into ROS and RNS. So those two groups together you call it as free radicals only. So these two group of free radicals will come from two sources. One can be the exogenous source, the other one is endogenous source. So you all know from the name, what do you mean by endogenous and exogenous? Endogenous means what? Endo means what? What is the meaning of endo? The normal English meaning of endo?
Inside, within.
Inside, right? So endogenous sources in the sense, whatever the reaction which is happening in your body, so all those processes also will generate free radicals. Both your ROS will be generated and RNS also will be generated. So for example, you have mitochondria, peroxisome, endoplasmic reticulum, phagocytic cells. In all these places, you will be generating ROS as well as RNS. So example, if you take mitochondria, you have electron transport chain mechanism. So when you translocate or transport the electron, you of course have oxygen in there because it is a respiratory process which is involved. So because of Q cycle, you may generate your ROS. Their oxygen species will be generated as free radical. And in case of your phagocytic cells and other endoplasmic reticulum cells, your system will only produce your ROS and RNS in order to fight against your bacteria or virus or any other microorganism which is entering in your living cell. So in order to kill those substances, your own phagocytic cell and your own body cell will be producing your ROS system to destroy those substances. You will be reading that in the immunology also. So those kind of ROS and RNS, if you are able to produce, you call that as endogenous sources, because inside your body itself you could able to produce for different purpose. It may be for different purpose. One may be to protect you, one may be to produce energy. So in different processes you could able to generate ROS. So those ROS will not affect your body because you have the redox system. So you will have your own antioxidant system which is existing in your body that will actually balance your free radical which is produced endogenously. Usually that only will happen. So once if your redox system balance is not existing, if you could not able to balance whatever the oxygen which you produce or ROS which you produce, then comes all your diseases and disruption of your biological structures. All those things will be taking place. So apart from your endogenous source, you also have exogenous source of production of your ROS and RNS, which includes all your pollutions. So in the pollutants, you have lead, cadmium, whatever the fumes which you are inhaling through your nostrils, whatever alcohol you're taking, tobacco smoke, heavy metal, whatever you could able to see on the environment or on the surface or on the surface of your external respiratory tract, whatsoever it is, which is not a normal biological component, all those substances are eligible to produce your ROS, which includes your radiation also. So all these things will cause exogenous production of ROS. So all those exogenous ROS as well as endogenous ROS will have the same property, except where it is produced will bring the differences. So all these ROS usually will increase the oxidative stress in your body. So it will always increases the oxidant level in the body. The oxidant level will be used by only the immunological system to destroy the microorganism. Otherwise, you don't require this oxidative stress which should be increased in your body in the normal condition. So what will happen? These oxidative stress, whatever you are producing, which will alter all the biological molecules, the major biological molecules, which includes nucleic acid, lipids and protein. So all these nucleic acids, lipids, protein will be altered by means of this increased oxidative stress. So now all these things are present in your body in case your oxidative stress you have increased. So usually you should have antioxidants. In case if it is not there, what will happen? Those free radicals will be trying to abstract your hydrogen. As I have told you earlier, it will just try to abstract the hydrogen from nucleic acid, lipids and proteins, and it will make all these biological molecules unstable in nature, so that it just goes and reacts continuously with the other existing biological molecules, which can be your protein or lipid or nucleic acid, whatsoever it is. In case if it goes and affects your nucleic acid directly, it leads to denaturation effect. Of course, you all know it leads to mutation if it is existing for a longer period of time. So now, based on the production, you are